Okay, we're in section 125 of the notes. As always, there'll be contents, there'll be examples, and then there's going to be exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF document that you're looking at now is being made available to the Prison Mathematics Project participants only. All right. This document will be published at a later date, and certainly if you're interested, if you're a teacher or a student that's not in the Prison Mathematics Project, what you need to do is reach out to me, and I'll update you about when it's going to get published. My email address is Bannon, that's B as in boy, the @ symbol, NNON.us. Well, let's take a look at the contents. And again, we're not reading the contents to you, you're reading the contents. You know, they talk about things, location of roots, yada, yada, yada. They talk about synthetic division, yada, yada, yada. Interesting kind of concept over here. Then we get to the examples. And again, the way I treat something might look a little bit different than Wells, but really, algebra really hasn't changed much. All right, but I do mention intermediate value theorem. This is my overview of things that are important. And certainly what I mean by that, if I'm looking for roots, the intermediate value theorem can be quite helpful for getting a location of it. So let me just point out what I mean by that. I'm going to write down f of x, and we're looking at number 1, by the way. So f of x equals, and this is x cubed, plus x squared, minus 5x, minus 4. What I want to claim to you that this is a cubic, and cubic problems, I'm going to say in general, look like this over here, all right? The leading coefficient being 1. Now, granted, someone says, well, do you know if it has roots? I know it has at least one root. What do you mean by that, a real root? It could have one root, but the bottom line, it could also have, multiple roots. Maybe I went a little too far with that. Let me erase this over here. So I'm going to say that, one possibility is this is the x-axis, by the way. The other possibility might look like this over here. I did it again. Let me erase this over here. I'm not trying to put a y-axis down. Right, that's crazy. I don't want to do that. I want to locate it. Just kind of looking at an x-axis again, and a thing might look like this over here. So one root, then come back down, and it might have 3 real roots. All right? So, there's many ways to bound these roots, and certainly that's a possibility. Determine, the counting of the roots. We know there's 3 of them, by the way. But what I do is just get a feel for it. And what I would recommend to do is, hoping that these things are going to be pretty close to the origin, and you kind of look around, all right? And what I would do is, maybe just start with 0 and write down f of 0. Now, someone says, why would you do that? Well, I know the function is negative there. It's minus 4. So someone says, what does that mean? Well, if you looked at the picture of it, all I know now, it's over here somewhere, all right? All I know is it's below the x-axis, all right? So then you might say to yourself, could you go to 1? And you could. And I'm going to say you could do that computation, and I'm going to recommend you do that. All right, now if you do that, you get 1 plus 1, that's 2, minus 5, that's minus 3, minus 4 is minus 7. Well, you know what? It's even gone lower. All right? But you get the idea. I still know it's negative. Now, to know exactly where it is not important, so I'm just going to simply say it's really important that you know this is less than 0 and this is less than 0. It's really important to know that. So I know it's below the x-axis. What am I really looking for? I'm looking for when does it puncture? When does it go through the x-axis? And the only way that could occur is if it ends up over here somewhere. All right, that's what I'm looking for. Now, someone said a lot of work to get there, and you're right, it might be a lot of work to get there, all right? But I'm going to claim over here, not that I want to go through all the arithmetic for you, but you should evaluate f of 2, and it's also negative, all right? So what do I know? So far, everything is below the x-axis, but then when I get to this one over here, what do I know? It punctures somewhere along the interval between 2 and 3. Let me write that down. Between the integer 2 and the integer 3, at 2, it was negative over here somewhere. And then at 3, it became positive. The only thing I know now is it must have went through. Now, someone says, could it go through more than once? Yes, it can. All right? I want to point out what the possibilities might be. And this might seem strange to you, and I'm not saying this is the case. But let me draw these in for you. I'm going to erase this over here. I'm going to tell you the possibilities of this now. For a cubic, anyway. It may go through once. As it goes up, it may come back down. and it may hit it right here and then go back up again. So I'm going to say it hit it here, hit it here. So it could be 2 times. You think so? Yeah, it could. And what would this be? It would be a repeated root. You'd have three real roots, but one of them is repeated. Let's talk about the other case. I'm going to erase this over here. Again, we're just talking about between 2 and 3. By the way, I'm not saying it does that. All I'm saying it could do that. What's the other case it could do between 2 and 3? Which seems rather unlikely. I know it's negative over here. It could go up, then it could come back down, and then it could go back up again. Why do I know that? It's got to hit a positive number up there. How many roots? 1, 2, 3. You know what? Let's take a look. I know there's a root, at least one, between 2 and 3. But there could be 1, there could be 2, there could be 3. But now I know there's one. I know there's at least one root between 2 and 3. I want to look around more. What I'm going to do over here is, and again, I'm not doing the computation for it, I'm hoping you can do it, but f of minus 1 turns out to be positive. So I want to, again, emphasize, let me erase this picture over here. I want to emphasize what that means to me for a polynomial. Again, we already know there's at least one root between 2 and 3. Now I'm talking about the numbers on the x-axis between 0 and the other number is going to be minus 1. Now what do I know? At 0, I know it evaluates to a negative number. And what do I know at minus 1? I know it's positive. So what do I know again? I know there's at least one root between that now. All right? So I know there's one root now. I'm going to write this down. I know at least one root between the interval 2 and 3. And there's a root over there, at least one. And I know there's at least one between minus 1 and 0. All right? You can keep going. This is positive, and then this is negative over here. So let's go for that again. Let's talk about it. It takes me to evaluate these things to do it. Let me get my eraser out. And let's put this down for you. And we'll get a rough picture of this thing. Don't worry about that. So let's take a look. Between minus 2 and minus 3. Well, at minus 2, it evaluates to be a positive number. And at minus 3, it's a negative number. So I know it goes through that too. I know it, at least one. Now, certainly, I know it's a cubic. I know there's going to be 3 roots. So let's put a graph down. I'm not going to say it's great, and we don't need to do great graphs, by the way. I'll put this over here. And let's see what I got. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Well, I know there's a y-intercept. That's really simple. That's really simple to come up with. I know there's a root between 2 and 3. Let me take a look at that. It's over here somewhere. I don't know where it is, but I know it's between there. All right, we'll talk about why I know it's only 1 now. I know there's a root between minus 1 and 0. That's over here. Again, I don't know exactly where it is, but I'm going to say it's between there. And what else do I know? I know there's a root between, what else do I know? Between minus 2 and minus 3, right? So I'm going to say over here somewhere. Now, I get a general idea of shape of this. All right, now, certainly when we exceed the upper root, it's going to be always positive. Then I'm going to say maybe something like that. I'm not saying I'm right, by the way. I'm saying maybe something like this. And it goes up. You can do sign analysis if you want, by the way, and something like this over here. I'm going to say a general shape of it. All right, so let me go to the key. I want to make sure you know what I'm looking at over here. So I know there's a root between minus 2 and minus 3. I'm going to point that out right over here. That's between minus 2 and minus 3. All right, there's a change in signs, right? It's got to be a 0 there. And that's really, we're using the intermediate value theorem. We generally abbreviate the intermediate value theorem, IVT. IVT. That's all I'm using over here, IVT. So I'm going to say, certainly I know there's a root there. And I know there's a root between minus 1 and 0. I'm just going to outline that for you over here. I know there's a root over there. And I know there's a root between 2 and 3. Right, I know that. And I get a general shape of it. By the way, I don't know if they provided a graph for you, but if you want, you can use the machine to do that. So look at that graph. Let's go through that. I knew there's a root over here. I know there's a root there, and there's a root over here. And I know the general shape of the curve, right? Again, that y-intercept was minus 4 as expected. Now, who does a better job of graphing? The machine does, no doubt about it. Now, this over here, I want to point out, for the most part, you give it a shot. I know it's tough, by the way. It's a really tough section, by the way. But this IVT is not tough. I recommend doing it, all right? I'd also recommend looking at what Wells does with this division and remainder stuff, all right? So anyway, illustration of the roots, we got that. And then you get the exercises over here. By the way, I often kind of question what Wells does. He does something that, I think rather complicated, and then he doesn't give many examples of it, and then he piles on the exercises, all right? So let's take a look at the pile on of the exercises. So I'm going to say these are the exercises. Number one, I'm using the IVT. I do provide a graph for you. I tell you where the roots are going to be using the IVT. I look at the graph and I reaffirm my belief that the roots are where they say they're going to be. This over here, location of the roots, I do that. IVT I'm still using. I think I'm going to be using IVT in this one over here. Yeah, it doesn't look bad. I'm using IVT just like we did for the example. This one over here, IVT again. I like the IVT. I think it's really good. It's good if you got really small numbers, but if you're really huge numbers for roots, this would not be a good technique to come out with. We'd need to get bounds. And even to get the bounds, you may want to just kind of push it back or translate or transform the function so the roots become smaller. And we've discussed ways to do that, by the way. All right. This one over here says prove that the equation has one root between this one. And you can do that using the IVT. All right. How do you do that? Show something's above and something below there, and you can do that. I do want to point out this is a tough read for a lot of students, but I do recommend you read through this stuff over here and try to make sense out of it. And I really do mean that. A lot of times when you're reading something, you say, oh, could you read it to me and explain it to me? Yeah, we can. But the thing is, that's not going to help you. What's going to start helping you is you read this, you get your paper and pencil out, and you start to understand things, including copying things down, expanding things as we emphasize, and going through the work as we do in the notes in the PDF. Look at it. This one over here, same thing. Maybe IVT. I think IVT again. But I do some of this business over here. Again, I would be looking at it, trying to make sense out of it. I also mentioned Descartes' rule of sign. Over here, again, looking at it, you got a nice little picture. Sage, what's Sage? It's a computer algebra system. CAS for short. It's open source, which means it's free. Go to this website. You can download it or use the interactive web-based application. I do things that are related to what we did in the topics. My goal here is to get you to do the work, paper and pencil, and that's the way Wells students would have done it. If you see any errors in my work, I'm not saying there's not error, there may be error. What are you going to do? You're going to reach out to me. You're going to tell me you're working a problem. And you might say, oh, gee, I'm on problem number 1 in section 125.3, and I believe you made an error. You might say to yourself, f of minus 4 is not 14, f of minus 4 is whatever. I'll take a look at it, and I'll take you seriously, and you'll get credit if you want credit. All right? You'll get credit if you want credit. But again, reach out to me. Don't feel like you have to reach out to me, but if you want to reach out to me, reach out to me. If I'm not overwhelmed, I will certainly entertain what you're telling me. If I get overwhelmed, though, I may not be able to entertain what you're telling me, but I'll make some attempt to do that, all right? What does overwhelming mean? If these videos become successful, you might get thousands of email messages. I can't sift through that. I don't have the time to do it, but I'll try to. I'm hoping that's going to be a moderate amount of people interested in this. And also, I want to say a moderate amount of people that might be interested, but even a less number of people that are interested enough that they're going to point out an error, all right? I'm really interested in people pointing out errors, though, and I will give you credit for that. Thank you for paying attention.